what do we have to do to make things thrive? Not just survive, but thrive.
Let's go. Let's go to space. Hello, everyone, and welcome to Fridays with Tim. I am Tim Alatorre, Chief Operating Officer for Orbital Assembly Corporation, and today is April 1st, 2022. No April Fool's jokes today. It's just, it happens to be the first Friday of the month, and so here we are. But so glad to be with you today. Lots to go over, lots of updates that happened in the last month. And once I get through those updates, then I'll get to your questions in chat. Feel free to drop those in there. We're on a new platform today. So typically what has happened in the past is we take your comments from chat, and then in post, we edit them and fix spelling errors and put them up on screen. Today, we're going to try something where we're actually going to put your chat text exactly from the stream on the video. So if your spelling is wrong, that's on you. And if there's something that's unclear in the question, then that might not be put on screen. But we're excited for this new platform. Hopefully it works better. And one of the benefits of this is we should be able to just go right from this to being posted on YouTube. There won't be a delay of a couple weeks like we've had in the past to do all the editing and production. That being said, start off with just to give you an update on engineering progress. This last month, we've been really working hard on actually the Pioneer Station work plan, and also the requirements matrix, and getting everything together so when funding's in place, we can jump right into the Pioneer Station fabrication. And so that's been the real focus this last week. Made a lot of significant progress with our partner, our vendor suppliers, and making sure that they're ready to go, working on getting more detailed pricing and really advancing everything we can with the resources we have available. So here's a shot of Voyager Station. That's coming down the line. That's not in the next project. Next big thing is we made a big announcement earlier this month that we've relocated and are planning to relocate the rest of our operations for the actually headquarters operations to the Huntsville, Alabama area. And this has been a process that actually we started back in August of 2020 when we were looking at where we wanted to set up for the long term. We had a facility in Southern California, but we examined 11 different regions across the United States, including where we were at in Southern California. And it came down to, well, actually, that's the short list was 11. We actually looked at international areas, but we settled on 11 US locations. And that came down to a final list of 3 regions, the Northern Alabama, Rocket City, Huntsville area, the Houston, Texas area, and Titusville, Kennedy Space Center, Florida area. And Huntsville came out on top there. And the things that we evaluated, buildings and real estate, also financial impact of moving to those locations. You're looking at synergistic opportunities with other partners, just the overall space culture, and what space infrastructure existed, the talent base. And that included educational facilities as well as other companies in the area who were attracting top talent. Also access to test facilities, as we're looking to test fairly large structures, which areas in the country had easy access to those testing facilities, and then launch access. The Huntsville, Alabama area actually has a unique situation in that this is where the Redstone rocket was developed, Atlas 1, Atlas 5 are tested, SLS was developed here, a lot of the shuttle program. Marshall Space Flight Center is still hosting and operating all of the science experiments on ISS. So there's a network of canals and rivers that make it very simple and easy for us to get to the various launch facilities that we need to get to. And then finally was quality of life, just cost of living, access to all the things that would attract top talent. So here's a couple shots from the Huntsville area. That's my daughter in the middle standing in front of the Space and Rocket Center here. That's an Atlas 5 mock-up. And the lower right-hand picture there, that's actually the port, the dock at Marshall Space Flight Center, where they launched all of the Atlas 5s. And to this day, SLS was tested at Marshall and then dropped on a barge there at that dock and sent on its way to the Cape. So lot of really rich space history here and a lot of top talent. And I myself have already started, my family and I, we relocated to the area, and we've been doing the ground here in Huntsville right now. And as funding and the rest of the team moves over here, we'll expand and get to a more permanent location. But really excited. The local, state, and regional governments have been incredibly supportive. And we also announced in our press release that we've negotiated a $3 million incentive package to help with the PSTAR gravitying program. And we look forward to future collaborations with the other professionals and the governments in the area. Also, some developments on our art contest. So we launched the art contest that I mentioned last Friday with Tim, and we've had a really good response to both the adult and the youth contests. But there's been a couple of developments. These are breaking news here in that. Oh, and I just saw in chat, Tom says, yeah, the Saturn V. I think it's an Atlas V. It's the Saturn V rocket. Talking fast and thinking at the same time doesn't always align. And good to see Tom Spilker, our CTO, in the chat today. Art contest, breaking news. We're working on actually creating a couple of press releases for these two announcements. They'll come out over the coming weeks. But Andre Bormanis, who many of you may know, has joined our cultural advisory board, and he's also going to be one of the judges for our art contest. And for those of you who don't know, Andre, he's written for a couple of television shows through the years, including 4 Star Trek television shows, and he's currently working on the Orville with Seth MacFarlane. So really excited to have him not only be a judge for our contest, but also for his continued input as one of our advisors. And then also, we've just inked, like today, an agreement with LifeShip. And like I said, there's a press release that'll be coming out about this soon. But LifeShip is currently collecting DNA and other artifacts and sending them to space. And they're working on creating DNA banks on the moon, as well as for people who are interested in having art or their ashes or imagery or their DNA sent to space. They're facilitating that. So they very generously offered to sponsor our art contest, and the 4 first place winners for the different categories will each have an opportunity. They'll be sent a DNA kit, and they can have the opportunity to have their DNA added to the DNA bank and sent to space. And also the top 300 art entries will have their art sent to the moon on their next available lunar mission, which is currently scheduled for 2023. So really grateful to LifeShip for their sponsorship and their partnership. And the MOU that we'll be talking about in the press release, we're also working with them to eventually send things to our stations as well as tourists. So really excited to have them as part of our partnership. And then last but not least, another press release that we're working on, which should be coming out fairly soon, is we're really excited that we have, and we've been working on developing this relationship for a number of months, but we've partnered with Dr. Mae Jemison of the 100-Year Starship Program and Dr. Ronki Olabisi, and I apologize, I've said her name wrong so many times. I probably said it again wrong right now, but she's with UC Irvine, the Samueli School of Engineering, to work on artificial gravity research. And specifically, Dr. Jemison, you may know, she is a former NASA astronaut, flew on the Space Shuttle Endeavour on STS-47. She has a medical degree with Cornell University Medical College. She works as a general practitioner for a number of years, worked in the Peace Corps as a doctor and medical researcher, and most recently she founded the Dorothy Jemison Foundation for Excellence, which was founded in honor of her late mother, and this fantastic work with helping youth. And then the 100-Year Starship Program, which is a DARPA-funded initiative, which is really looking at how to sustain efforts for enabling interstellar human space travel. And both she and Dr. Olabisi, who has also a very distinguished career and a number of credentials, has a PhD in biomedical engineering, the two of them are working together already on studying how microgravity affects human physiology. And so we're going to be partnering with them to look at the artificial gravity side of things and compiling what studies and research have been done, and also Dr. Jemison's own personal experience and ongoing research, and trying to figure out how we can best support human health in using artificial gravity on our stations. So really excited about that, and there'll be more on that in the coming months as we continue to work with them. Also, just a reminder, our net capital raise is still ongoing. The link is there on the screen, and we did extend the raise to the maximum actually allowed by the SEC. And our fundraising efforts are taking two tracks right now. We're leaving the raise open, but we're also working on reaching out and talking about our opportunities with larger accredited investors, investment bankers, high net worth individuals, venture capitalist funds, and we're moving into our formal Reg D offering, which will be kicking off very shortly. So both those tracks combined, to get the funding we need to stay on schedule. So with that, that's my overview, and we'll turn the rest of the time over here to questions in chat. So I'm going to come over here. We'll look at this. Let's see. So we've got a question here from Benny. He's saying, how many launches would it take to build the gravity ring? The gravity ring is actually designed to be a single launch mission, and that would be the PSTAR and gravity ring would launch in a single launch. Let's see. So and there's a couple questions here about gravity ring and PSTAR. Not prepared to talk about those today. We'll be making an announcement about that in the near future. But let's see here. Coming down here, we got some highs and some hellos. And let's see here. We've got Aiden is asking, will there be an age requirement to stay on the Voyager or Pioneer class stations? These kind of questions are challenging in that they're really determined to a large degree by our launch partners. Currently, we don't have any age restrictions that we're setting for visiting the station. I would imagine that early visitors to the station would be, the age of majority, adults, and over time, our goal is to make space accessible for everybody, and so that would include children and minors, and at some point we have to learn how as a species to reproduce off Earth, and so we'll have people of all ages. Let's see, lots of comments in chat today. I'm going to try to skim these fairly quickly. Leon's asking, can you all add pods side by side to increase living space on the single ring? So this image I have right here, this is a Voyager station. Pioneer station uses similar pods, or habitats as we call them. And yes, we could have multiple rings in sequence to increase the habitable area. Let's see. Okay. Sorry, guys. Chat is live today. I'm trying to keep up with it. Okay, so question here from David saying, will the spin up and down be done with cold gas or hot gas thrusters, assuming that can't be done with reaction wheels? You're correct. We would not be reusing reaction wheels. We're actually planning on hot gas thrusters because of the force required to do the spin up and spin down operations. Let's see. Aiden's asking, could ion thrusters be used to spin and despin the Pioneer and Voyager class stations? Theoretically, yes, but it would take an incredibly long time. So the thing about ion thrusters is they don't have a really high amount of force, right? So it would be a very long process. So we're using more traditional rocket engines for the spin up and spin down. One of the benefits of ion thrusters, though, is you don't have the same propellant requirements. Very, very high efficiency. One of the things with spin up and spin down, also, Voyager would have very consistent rotation rate. It wouldn't be changing the rotation rate very often. Pioneer, those stations are designed more for variable spin rates, to where we can spin them up, spin them down, test different gravity levels, be able to have customers who are doing manufacturing or research using different gravity levels. So So for that, we want to have more dynamic control over those spin rates. So Bobo 100 is saying you wouldn't need thrusters for very long because there isn't air resistance to stop them from spinning. There is actually a certain amount of friction and air resistance. The atmospheric drag's a lot lower than it is on Earth, but there is some drag and then friction with other station components. But you're right in that you only fire the thrusters to spin up, and then you turn them off, and then because of momentum, they would continue spinning. Very similar if you ever take a top and you spin it on the table, you apply the force to the top once, and if there weren't air resistance and friction with the surface that it's spinning on, that top would spin indefinitely without additional force inputs. Okay, well that looks like about it. Let me just go back up here and I'll just scan again. There's a lot of conversations about thrusters, and the thruster situation is an interesting one. For Pioneer, that mission, and Voyager, that mission as well, there's different thrust requirements that we're going to have for those different missions. The different phases of Pioneer Station, for example, the early phases don't need as robust thrusters as the second phase, and Voyager would need a class of thrusters even bigger than that. So we're having ongoing conversations with a number of different vendors for those propulsion systems, and ideally finding one singular vendor who could supply all of our different thruster needs. But it may be that those are split between a couple of different companies. Let's just see. Coming back up here. One of the challenges with this format I'm seeing is there's more of a dialogue. You guys are having more of a conversation, which makes it hard for me to pick out the pictures or the questions. But oh, here we go. We got some more here. So John's asking another question here about well, this is like part 5 of some four-part thing. I'm guessing. It says, what mechanisms will be in place if a truss gets stuck in the PSTAR? So yeah, this is a PSTAR question, but the goal would be to not have them get stuck. That's priority number 1. So all the mechanisms on PSTAR have been designed to minimize or eliminate the possibility of stickage, and then all the different components, truss components in the truss machine can apply additional force if needed to unstick components. If you recall back to the D-Star demonstration event that we did down in our Southern California facility, we had some pusher mechanisms at the back of the truss, and those actually could exert a tremendous amount of force if needed. And so it'd be the same with PSTAR. Now, you wouldn't really want to force something too much, because at some point it's going to give, and then you've got the truss flying out the other end. So having all that balanced and running multiple tests, those are all critical pieces to those on-orbit assembly processes. Benny's asking how high from Earth. I'm guessing you're talking about Pioneer, and right now we're looking around 550 kilometers in altitude for that. Ray's asking, are you still planning to use SpaceX's Starship for launches? We've actually never discussed who we're using for our launches. We're a huge fan of SpaceX, and we're watching closely what they're doing with Starship, and we've talked with pretty much all the major launch providers at this point, but we haven't made an announcement yet of our launch provider. Let's see. And then we've got a question here from John. He's asking what percentage of occupation of the gravity ring has already been sold. So we are actually looking for customers for a number of different missions, and that's not information that I can discuss on this call today as far as what has been sold. I will say that there's a lot of interested parties, and we've got some really there's a lot of excitement about doing research on artificial gravity platforms. We've never had an artificial gravity platform on orbit before, and so that's something that there's a lot of attention and interest in. And then as we're able to, we'll make announcements and send out press releases. Like we've made a press release previously about Leo Cloud flying on our platforms, for example. Let's see here. We got some more. So Aiden's asking, were either of the stations inspired by the TV show Lost in Space? I don't think consciously any of our stations were necessarily inspired by any particular station design. Obviously, there's been lots of rotating stations in popular culture and science for hundreds of years. Our approach has been one of looking at the physics and going back to first principles and building up from there. So we didn't take, you know, an image of a station. Like a lot of people think our Voyager station looks like 2001, you know, the hotel from 2001 Space Odyssey. It wasn't like we took that and said, hey, let's see how to make that reality. We started with, how do we most efficiently generate artificial gravity and assemble a station to create artificial gravity on orbit? And we worked out from there, right? So that's our design methodology. And I'm actually not familiar with the space stations on Lost in Space. I'm not sure if you mean the reboot or the, you know, the 1950s version, but I'll go back and look at that. But there's been a lot of different stations. Elysium has been one that I'm seeing pop up in chat here as well. But those haven't been consciously an inspiration for any of our designs. So Dave is asking, does it mean the station will be able to perform its own reboost unlike ISS? Yes, all of our stations are designed to be able to perform their own reboosts and not rely on a servicing craft to do that. And then, yeah, so Tom's in chat here, our CTO. He's saying, yes, we can use the same thrusters for spin up, spin down, and precession for orbit reboost. So yeah, great question, because right now on ISS, the ISS actually has some ability to do maneuvering and reboost to a certain degree, but it's more of a propellant issue. And the engines on ISS aren't as efficient as the engines that are on the docking craft. So they like to use the docking craft because they can bring up propellant for that maneuver, and then they typically have larger engines to be able to do those maneuvers. And then the nice thing about having you know, the rotating environment with the thrusters on the outside of the circle, right? So that we have the circle rotating, thrusters on the outside. That's for spin up, spin down. We can also fire those in different combinations to you know, maneuver the station and do reboost. Let's see. So, question here from Leon is asking, are you prepared to provide status of external manned robotic assembly vehicles? So, Orbital Assembly Corporation has actually never, we haven't ever developed or planned on using external manned robotic assembly vehicles. I'm guessing you're meaning like pods or something where a person's riding inside of it. We are working with Rogue Space to do a semi-autonomous unmanned robotic. Let me see if I can rephrase that sentence. Working with Rogue Space to use unmanned robotic vehicles for extravehicular operations. So Rogue Space has a number of different drone, you know, semi-autonomous robots they're developing, and we currently have an agreement in place with them for using their craft on our early missions. The most simple of their craft is called the Alatorre, which is a drone that's used primarily for observation and measurement and inspection. So as we're assembling and doing orbital operations, we can have a free flying camera basically to be able to look at all the different angles and make sure everything is happening in the order and sequence that we want it to be happening in. And then they also have another craft called Fred, which has manipulator arms, which we can use to move things into place and position them. There's another craft they also have for very fine-tuned operations. So between, you know, these different workhorses, we can move things, we can attach wires, do bolting, you know, whatever we might need to do, and we can either control that from the ground, or we can have people on station controlling it, you know, right there via the local Wi-Fi network, direct control for these vehicles. So we feel that that's a more safe approach than having manned EVA. And also the other thing with you know, these manned extravehicular vehicles is there's a lot of R&D and safety concerns and a time delay before they're ready. So at some point, I think that technology will be something that we're going to, look into once it's commercially available. But we're not really developing those tools. We're looking at what is available right now on the market or what is available in the near term, such as Rogue Spaces crafts. Yeah, Tom, just back on the reboost question here, he makes a good point. We don't have to despin for reboost or other delta V maneuvers. And I'm not sure if I gave that impression earlier, but with the position of our thrusters on the outer ring, we can do all those maneuvers while it's spinning, which is pretty cool. Okay, I think we're back at the end of chat here. Thank you all so much for participating today. Like I said, chat is a lot more lively place now, which is kind of fun. I appreciate that. So we'll have another call. We're planning on the first Friday of now May, which will be a month from now. And thank you all for your support. And look for these other press releases and things coming out, and more exciting things ahead. There's actually quite a bit planned for this coming month, and as that all unfolds and develops, we'll share it with you. So thank you so much, and we'll talk to you next time. Bye.